Hello and welcome to Scientific Games, technical training video that will demonstrate how to upgrade the Fusion Auto Roulette wheel with the latest firmware. The purpose of this firmware upgrade for both the dual direction and single direction wheels are: it optimizes error handling, which results in less tilts and increases reliability, and total spins has been reduced, which results in more spins per hour. To give a breakdown on the tilts corrected, they are as follows. Balls that did not properly launch from the tube has been corrected. Balls that entered in the wrong launch tube for dual direction only has been corrected. For diverters that did not cycle all the way, for dual direction again only, that has been corrected. For the WNR sensor failures, it now reports a tilt. Balls getting stuck under the hat has also been fixed. And lastly, balls launched too slow to make it around the rim 3 times has also been corrected. Again, tilt recovery was implemented to reduce the amount of time the game was down. Before starting, as depicted, the following are the required parts and kits needed. You will have a USB thumb drive that has the firmware, as well as you will receive a USB serial cable with the CD driver. The firmware process should take approximately 15 minutes to complete. It will require one person for this upgrade. To ensure the upgrade goes successfully, we found that we must check our WNR sensors. If they are not functioning properly, it would cause other issues. So let's take a look at how we can check them before performing the upgrade. On the Rabbit control board, you will see jumper connections labeled CON 14. They are used to diagnose or test certain sensors on the wheel. Below this, you will see a row of LED lights, D6 to D15. To learn more, please refer to either the manual number SMM-0070 Rev B or the service bulletin labeled VSLW, the sensor diagnostics. Each of these will be attached in our SG Learning under Bulletins. Note, the power must be on and ensure that all the dip switches are turned off. Back to checking the WNR sensors. The following are the jumpers we need to use to check each WNR sensor. 1, 4, and 7. What we are looking for after the jumpers is in place and when turning the wheel is for the LEDs to flash. Each LED represents a value of 10% contact strength. The ideal value is, of course, 100%. If the LEDs are off, this means that the sensors cannot see each other. Thus, the signal beam of the transmitting diode is blocked. As being demonstrated on one screen, I am showing 2 screens, one of the LEDs flashing and the other showing a person turning the wheel with the jumpers on a particular position. The diode starts at D6 and goes to D15 if the sensor is working properly. Note, as you can see, the wheel is being turned slowly. If it is turned too quick, you will see the lights at a constant flash. The lights do react based on how fast the wheel is being turned. If not, we will need to troubleshoot and identify what the issue may be and if parts should be ordered. Provided when turning the wheel for each of the jumper for the LEDs 1, 4, and 7, we can now perform the firmware upgrade. Starting with the PC, go to the Start menu and type Device Manager as shown. Select Device Manager. Look at the port section and verify that the serial adapter is present. If shown under Ports, you can continue with the setup of the serial adapter to communicate to the control board. If not, here I am showing you how to add the drivers so that you are able to use the serial adapter and continue with the firmware installation. Select under Other Devices the USB serial as seen here in the diagram. From your choices, select Update Drivers. From here, you will be prompted, how do you want to search for drivers? Select Browse My Computer. From here, you will navigate to the thumb drive you received with the kit and select the folder with the USB serial drivers. Follow the prompts on the screen to complete the upgrade. At the end, you will see a wizard that will state the update was successful. You can now go back to the Device Manager, and under Ports, you should see the serial adapter appear and it will have a port number after it. Note, looking at the port section, you will see USB serial port with COM and an X or a number. The X is representing the port number, and in my example, you see 5. Once verified, we can now have the information we will need for communication between our laptop and the control board later. Starting with your laptop, insert the USB thumb drive into your laptop. Open File Explorer. To do this, hold down the Windows key plus the E key. Navigate to the USB drive and open. Once open, you should see 3 folders: Firmware, Rapid Flash, and USB to serial drivers. There's also an instruction manual to assist if needed. Next, we need to establish and verify our connection between the control board. First, we must turn off power to the wheel. Using a flathead screwdriver, again as being demonstrated, loosen the 4 screws on the control board cover. Remove the cover and set aside for later. Using the programming connector from the kit, connect this to the serial port on the control board. Now, on the control board, we can turn the switches to the on position as shown. At this point, we're physically connected to the control board, but we need to verify the communication ports are set correctly. To verify the port settings, we will need to open our Rapid Flash folder. Using Windows Explorer, navigate to the USB thumb drive we've inserted into our laptop. Open the thumb drive. Once open, navigate to the Rapid folder. Open this and look for the RFU folder. Double-click this. Once open, the wizard will appear. From your choices, select the Setup tab. Select under this tab the choice Communications. You again will see a wizard appear. Here we will set up our baud rate and set the communication port we verified earlier during the preparation. We will also verify that the following boxes are checked on this wizard. That will be the Use USB to Serial Converter. After all this has been verified, we can now select OK. We are now ready to select all the files or drivers to perform this upgrade. So with the Rabbit still open, under the Setup tab, select File Locations. Again, another wizard appears. Note, all files that are needed should be auto-discovered, but if not, follow this process to upload each one. Starting with our code loader, you will see 3 little dots, which are called ellipses, located to the right. Click the ellipsis symbol. This will allow you to browse your computer. Navigate to the thumb drive and open it. Once open, select the code loader.bin file. Then select OK. We will repeat this process for our pilot BIOS and the flash table, as we're demonstrating in the video now. Once all the files have been selected, we are now ready to upload the files. Select OK again. This loads all the bins required for this software firmware upgrade. Next, we need to verify the game versions we are running on the terminals and identify the type motor controller we have. Starting, we have 2 motor controllers, the SK Commander and the M200. Depending on the motor controller and game version, we will use this chart to determine what versions of software is used. As shown, in the left-hand column, I am showing you the various type wheels we have, both dual direction and single direction. Right next to that, I am showing you the Agile program number that you will be using when doing this firmware upgrade. To the right of that, I am also showing you the game versions. We have 2 types, V4MU 0123 as well as V4MU 0128. Right below that, depending on your game version, these are the programs that you will be using to upload this new firmware. Next, we need to identify the game software version. Here we need to go to the terminals and open the machine identification menu and verify the firmware identifications as being shown here. We can start the load flash image process. Again, as being demonstrated, we will now select our File tab under the Rabbit program. Under this tab, you will see the Load Flash image. Select it and the wizard appears. Here we have to navigate to where the drivers are. So again, using the ellipsis, navigate to open the thumb drive. Remember, click the folder that corresponds with the wheel type and the motor controller you have on the wheel. Select the correct folder. Once open, select the bin file and click Open. Allow this process to complete. Here you will observe the code loader, your pilot BIOS, and the flash tables are now being loaded. Allow this process to complete. Now we are ready to power the wheel off and turn off the dip switches. Once completed, our task of upgrading the firmware has been completed. Remember to place the cover over the control board before continuing the upgrade. Now we need to verify the firmware has updated. Again, go back to your terminal. Turn your attendant key to access the operator's menu. Once open, we need to navigate to our test menu. Once highlighted, touch the select key. On this menu, you will then toggle through the menus Test Menu, Game Test, Roulette, and lastly, Game Cycle Statistics menu. Once at this menu, Game Cycle Statistics, look at the bottom of the screen and look to see what we have for the wheel firmware info. Note, here, verify the new firmware number matches the upgraded firmware number. Next, we need to perform our motor controller calibration. This process shown is only for the M200 controller. For the SK parameter settings are pre-programmed before delivery and it should not be manipulated via the keyboard at any point. After updating the firmware, we must calibrate our motor controller. Again, as stated, this process is only performed for the M200 motor controller. Power on the roulette. As shown in the photo, starting from the left side, you have the return button. Next, you have the down arrow. And below that, you see what each code scene represents. Moving to the right side and starting from the top, the first thing is our LED display. This is a visual tool used when I'm entering information. Below that, we have the enter button to allow you to enter your selected choice. Right below that, you have the up arrow, and directly below that, that is the reset button. Now that we've identified the buttons, we can now move into calibrating the motor controller unit. To start the calibration, turn on the power to the wheel. Next, on the motor controller, press the enter button. Here you should see the value 00.010 appear on the display. Press the return button once. From here, using your up or down arrow, press it until the LED display the value of 05. Here you should just see the 05 flashing. If so, press enter. Here you will see the next octave flashing, the .000. Using your up or down arrow again, press it until the display shows 0.015. Press enter. On the display, after you press enter, you should see 15.0 being displayed. If not, use your up and down arrow to have the 15.0 displayed. From here, press the return button. Now we need to use the up and down arrow to change our display to read 5.0 again. Once here, we can press enter to save our changes. When enter is pressed, the display will change to none. Again, we want to press enter. This time, the word none will flash. Using your up and down arrow again, toggle until you see the word save. Once this is displayed, press the enter button once more. We have now entered our new settings, so the last thing to complete will be reset the motor controller. To do this, simply press the reset button. This will complete the calibration portion. Congratulations, you've successfully completed the firmware upgrade. Thank you for taking the time to view this material. For further assistance, please reach out to our central site or technical training team regarding material. Thank you.